Good morning, friends. We'll now start thermography again. That is something extra. Temperature is expressed in either absolute or relative terms. There are two absolute scales called Rankine, English system, Kelvin, metric system. The two corresponding relative scales called Fahrenheit, English system, Celsius, metric system. Absolute zero is the temperature at which no molecular action takes place. This is expressed as 0 Kelvin or 0 degrees Rankine. The relative temperature is expressed in degrees Celsius, degrees Fahrenheit, so T Celsius equal to 5 by 9 T Fahrenheit minus 32. This is coming from, say, 1 Celsius. Celsius is divided from 0 to 100, and this is Fahrenheit is divided minus 32 to 180. So it is coming from there, 100 divided by 180 and 32 difference. That's all. So just remember in this way, T Celsius equal to T Fahrenheit minus 32 divided by 1.8. T Fahrenheit equal to 1.8 T Celsius plus 32. So because Fahrenheit is bigger, so 1.8 plus 32. This is T minus 32 divided by 1.8. T Rankine equal to T Fahrenheit plus 460. 459.7 is 460. T Kelvin. T Celsius plus 273. Absolute zero is equal to minus 273 degrees Celsius. Infrared in the electromagnetic spectrum. We'll again see this. This is visible infrared and this is radio wave. So these are the wavelength. See, these are called wavelengths. So wavelength, if you see, wavelength increases and wavelength decreases. When decreases, it is going for visible. Increases going for radio wave. In between radio wave and visible. So when decreases means decreases while hot will decrease and go for visible red. The temperature increase, this will decrease, wavelength decrease. So reflection, radiation, emission, radiation, transmission, radiation, all combined is one. Total energy. The total energy is absorbed energy, transmitted energy, reflected energy, all combined. Typical black body distribution curves, basic radiation. Not steady state, that is transient. 6000 sun, 3000 tungsten filament, 800K element, 300K human body, 77K liquid nitrogen, 195K dry ice. So everything like this. Stephen Boltzmann law, radiant flux, W equal to sigma epsilon T4. Sigma equal to 5.673 into 10 to the power minus 12 Weber per centimeter square per Kelvin minus 4. So epsilon emissivity, Stephen Boltzmann constant, sigma. T is the temperature in Kelvin. When's displacement law, lambda equal to peak wavelength. Peak wavelength is 2897 or 3000 divided by temperature in Kelvin. So this is telling while heat is increased, then it is going to spectral distribution of energy radiating from various sides last function of surface. Very hot targets radiate in the visible as well as our eyes can see this. So this is a black body. The target relative spectral radiance, wavelength, wavelength of a black body. This is for a gray body, and this is a non-gray body or real body. This transmission of ground level atmosphere, transmission of absorption of reflectance characteristic of glass. If the transmission is good means you can put a window of glass for the camera. So this is good for 1 to 4 micrometer wavelength region. This window. This is also for air transmission. So if you see from 6 to 14, 6, 7 to 14 is okay. Here up to, this is not so good, but okay, so what? So air transmission here for gases is slightly problem. And glass transmission, so glass window can be used for this region. And germanium is very good transmission from, you can say from 1.5 to 20. So this is used as a window for air coated 10 micrometer. Good window for thermal cameras. KRS5 also good, but this may be costly. Zinc selenide. Other things are not so good. At a temperature of absolute zero, all molecular motion ceases. Molecular motion is not there. So there is you cannot read, no thermal activity, nothing, no thermal radiation. Conductive heat transfer cannot take place. So conductive, then across a vacuum. It cannot take place in vacuum. Radiation, okay. Only three modes of heat transfer are conduction, convection, and absorption. No, conduction, convection, and radiation. See, heat can only flow in the direction from hotter object to colder object. Thermal resistance is inversely proportional to the rate of heat flow by conduction. It is resistance. The radiation of thermal infrared energy from a target surface occurs most efficiently in a vacuum. Okay, is proportional to the fourth power of the absolute surface temperature. Is directly proportional to surface emissivity. All of the above. All of the above is the answer. The mode of heat transfer most closely associated with infrared thermography is radiation. E. To convert a Fahrenheit reading to Celsius, subtract 32 divided by 1.8. Thermal radiation reaching the surface on an object can be thermal radiation reaching the surface of an object can be absorbed, reflected, and transmitted. The following spectral band is included in the infrared spectrum: 0.75 to 100 micrometer. Most instruments used in infrared thermography operate somewhere within 2 to 14 micrometer spectral region. As the surface cools, the peak of the radiation infrared energy shifts to the longer wavelength, that is fine slope. The longer wavelength you can see it is coming towards visible. That's the peak emitting wavelength 300 degrees centigrade black body is approximately just 3000 by 300 degrees Kelvin. Go for 375, so 600. So 3000 by 600 equal to about 5 micrometer. Or degrees Kelvin, Wayne's law, 3000 divided by T in degrees Kelvin, 5 micrometer. 300 degrees centigrade plus 370, 271. So 271 if you add, you'll get 5 to 6, something like that. An opaque surface with emissivity of 0.04 would be a fairly good reflector. Emissivity very less, so 1 minus all reflect. If a surface has an emissivity of 0.35 and reflectivity of 0.545, add these two and minus from 1, you get 2.2. The force convection, the boundary layer decreases as the fluid velocity increases. When hitting one end of the car key to a throw up frozen automobile door lock, heat transfer from the key the lock is the example of conductive heat transfer. This conduction. There is no convection and all. The infrared atmospheric window that transmits infrared radiation best is 9 to 11 micrometer region. Leave this one for not for you. The spectral band in which glass transmits infrared radiation is 2 to 3 micrometer region. The reflectance of infrared radiation by a glass surface is greater in 9 to 11 micrometer. This is also not for you. A diffuse reflecting surface is a surface that scatters reflected energy in many directions. In the 8 to 14 micrometer spectral region, the atmosphere transmits infrared energy very efficiently. That is the figure if you see. This one for air. The temperature again we'll see. Celsius equal to 5 by 90 minus 32 bracket T minus 32 divided by 1.8 is 1.8 of T plus 32. Fahrenheit is this Celsius. Rankine equal to Fahrenheit plus 460. Kelvin equal to Celsius plus 273. So you can convert easily. The angle has a problem. The emissivity will having problem with angle. The best way to determine the effective emissivity of a target surface is to measure the effective emissivity of the material itself or a similar sample. For an opaque gray body target surface, emissivity equals to opaque gray body. That means it is not transmitting anything. Say 1 minus reflectivity. Transmittivity is 0. Just understand the question. The effective emissivity of a surface is always affected by the material, surface texture, and the viewing angle. The measuring of temperature of a non-gray body targets errors may be caused by hot sources behind the target. The effective emissivity of a target surface can vary at different wavelengths. Yes. A different wavelength means with the temperature. Temperature, it will vary. Variation. Variable. Emissivity is not constant, but we are using some constant so that we get something. Unfinished, unoxidized metal surface usually have low and uniform emissivities. Thermal diffusivity high for metal and low for porous material. Thermal diffusivity is related to more to transient heat flow than steady state flow. That will not go up for you. Thermal capacitance. It expresses the heat capacity of a material in a form of analogous to electrical capacitance. So thermal capacitance of water is more. That's a highly textured surface is said to be diffuse. A smooth surface is to be specular. Going too much to this. No need. These pictures are called thermograms. Thermal images are called thermograms. Okay, thank you, gentlemen.